Welcome. Today we will study about some basic concepts of the thermodynamics. First of all, let us see this definition. It is the branch of science that deals with energy and energy interactions and its effects on system and surrounding. We know that if a system is there, it will have some energy. So how this energy will interact between the system and surrounding, this is studied under the subject of thermodynamics. Now, what is energy? Energy can be defined as the ability to cause some changes in the system. It is the ability of the system to cause changes. Now, what is system? A system is a fixed mass in which our study is focused. As you can see in this diagram, that system is bounded by a boundary, and outside the system, everything is called as surroundings. So, everything outside the system boundary is called as the surrounding. One thing you have to keep in mind that the part of the surrounding that is affected by the system is called as immediate surrounding. Now, what separates the system and surrounding is boundary. A real or imaginary surface that separates system from surrounding. A boundary can be fixed or movable. As you can see in this diagram, that this is the piston cylinder arrangement. The bottom part of the cylinder is fixed boundary and the piston which is the movable boundary, and the system is gas inside the cylinder, and this dotted line is represented as the imaginary boundary. Now let us see what are the types of system. The first one is open system. In open system, mass can transfer between systems and surrounding. Energy transfer can also take place. Examples of the open system are piston cylinder arrangement with valves, nozzles, turbines, closed system. In closed system, there is no mass transfer, but energy can transfer between system and surrounding. Example is piston cylinder arrangement without valves. Isolated system, sorry, isolated system. In isolated system, there is no mass transfer and there is no energy transfer between the system and surrounding. A perfectly insulated thermoflask is the example of an isolated system. Now let us see what is pressure. First of all, in gases, we will see how pressure is generated in gases. In gases, the pressure is the average normal force per unit area. So we will see that in gases, the colliding mass of the particles is directly proportional to the density of the particles, density of the gas. Colliding velocity of the particles is equal to under root of 3 RT by m. So we get the root mean square velocity, that is the colliding velocity of the particles, is directly proportional to the square root of the temperature. So by this we get pressure in the gas is a function of density and temperature. In liquids, the pressure in liquids is due to the repulsive forces between the molecules. Now we will study that what is property. So as we know that any system has some property, so what is the definition of property? We will look here. Any characteristic of a system by which the system is defined is called as property of the system. There are two types of properties. First one is intensive property and second one is extensive property. Now intensive properties are those properties which do not depend on the mass of the system. These, if mass of the system changes, then these properties will not changes, such as pressure, temperature, density, velocity. Now the one thing you have to keep in mind that all the specific properties are intensive properties, such as specific volume, specific internal energy, specific enthalpy. Extensive properties, these properties are dependent on the mass of the system, such as internal energy, enthalpy, entropy. Now we will see about microscopic and macroscopic approach. In macroscopic approach, the individual molecular behavior is neglected and the average behavior is taken into consideration. So we will not go through the molecular level. The average behavior is considered in the macroscopic approach. This approach is valid till the continuum concept hold good. So we will now look what is continuum. In this concept, the matter is considered to be continuously distributed with no holes being present. Continuum means continuity. So we assume that the matter is continuously distributed in the system. So now continuum concept is valid till mean free path of the molecule is much smaller than the system dimension. Now in microscopic approach, we will consider the molecular behavior. So molecular, we will study at the molecular level in the microscopic approach. Now what is the state and what is process? Any condition of the system is called state of the system. So whatever is the condition of the system at any instant, that is called as the state of the system. The state of the system is specified by its properties. If any one of the property changes, state of the system changes. So if any property of the system changes, the state of the system changes. Now the change in the state of the system is called as the process. The infinite states through which the system passed while moving from initial to a final state is called process path. So if a process occurred from state 1 to state 2, then it will call as the process path of this process. Processes can be defined as quasi-static or quasi-equilibrium and non-quasi-statics. So if a process occurs infinitely slowly, it is called as quasi-static, or otherwise it will be non-quasi-static. Quasi means almost and static means rest. So when a process goes from state 1 to state 2, then it will move very slowly, infinitely many states. So this will called as quasi-static process. The quasi-static process is represented by a joint line on the property diagram, whereas a non-quasi-static process is generally represented by the dashed line. As you can see in this PV diagram, that the joint line represents the quasi-static process and the dotted line represents the non-quasi-static process. A reversible and irreversible process. The process is said to be reversible if it can be reversed in the direction following the same path as that of the forward process without leaving any effect on the system and surrounding. So if this process 1 to 2 can follow the same path, then it will be called as reversible process, otherwise it will be irreversible process. One thing you have to keep in mind that all the natural processes are irreversible process. Now one important concept is that every quasi-static process is not reversible, but every reversible process is the quasi-static process. Okay, now we will see about thermodynamic equilibrium. A system is said to be in thermodynamic equilibrium if it satisfies the following types of equilibrium. First one is thermal equilibrium. In the system, there will not be any temperature difference. That means temperature must be uniform throughout the system. So here you can see in the diagram that at below there is 35 degrees C temperature and at above there is 42 degrees C. So this is not thermal equilibrium. In mechanical equilibrium, the pressure at any point must be uniform. So here we can see in this diagram that the pressure is different, so it will not be in equilibrium. The third one needs to be in chemical equilibrium. So the chemical composition of the system should not change with time. So as we can see, O2 and N2, phase equilibrium. The amount of each phase of the system should not change with time. As you can see that there are two phases in this, H2O at a vapor phase, H2O at liquid phase. So these phases should not change with time to attain the thermodynamic equilibrium. So this is all for today. We will see in the next class. Thank you.